Hello and welcome to tribetopper.com.
And you're watching this video on the solutions for IGCSE past papers. So a question reads, a large stone block is to be part of a harbour wall and the block is supported beneath the surface of the sea by a cable from a crane, and the cable is shown here. So this shows the block with its top surface, this is the top surface, at a distance h. So this height is h below the water level or the surface of the sea, and the force acting downwards on the top face of the block due to the atmosphere and the depth h of water is 3.5 into 10 to the power 4 Newton. So you have to understand first thing here that we are given the total force acting on this part of the block, and that is at a height or at a depth h below the surface of the sea water. We are given the force. For the same block where that force is acting, the top face of the block, its area is given to be 0.25 meters square. So calculate the pressure on the top face of the block. So first step is, please write the correct formula. We would write, since pressure is equal to force upon area, and we are given both. The force acting, now just plug in the correct values. So the force acting on the top face is 3.5 into 10 to the power 4 Newton upon area. Area of the top face is 0.25 meters square. And when you solve this, you would get 1.4 times 10 to the power 5 Pascal. So that's the pressure acting on the top face of the block. In the second part, they say the atmospheric pressure is 1 into 10 to the power 5 Pascal. Then what is the pressure on the top face of the block due to the depth h of water? Now see, there are two things which are exerting a pressure. One is the atmospheric pressure and the other is that depth of water which is exerting that liquid column which is exerting the pressure. So we calculated the total pressure to be this much in the first part. So we'll just subtract the atmospheric pressure from this. This is just a 1 mark question. So we would say the pressure on the top face of the block, due to the liquid column, we can say, or due to the column of water, is just equal to the total pressure that we calculated, 1.4 times 10 to the power 5. Out of that you subtract the atmospheric pressure, which is 1. So we get the pressure due to the liquid column as just 0.4 into 10 to the power 5, or we can also write it as 4 times 10 to the power 4 Pascal. Right? So we have just got the answer by subtracting the total pressure. We subtract the atmospheric pressure out of the total pressure. Further, they say the density of seawater is 1020 kg per meter cube. So calculate the depth. Here we use the formula for the pressure exerted by liquid column of height h or depth h. So P is equal to h, the depth of the liquid column, times rho, the density of the liquid columns, times g, the acceleration due to gravity. Now we just calculated P in the previous part, which is 4 times 10 to the power 4 Pascal. So just plug in the correct values now. For pressure, we put it here, 4 times 10 to the power 4 is equal to h, we have to calculate, times rho, it is given here, the density of the seawater, 1020, times g, for the sake of convenience, would take it as 10. Therefore, when you just rearrange the terms, you get h as 4 into 10 to the power 4 upon 10200, and solving this you would get a height of 3.9 meters, which you can approximately write as 4 meters. Now they say suggest two